Hello everyone. In this video we're going to be solving a number theory puzzle, an age problem. "Don't be late now," said Susan. "Your grandfather is coming over. It's his birthday, you know." David nodded. "Sure, and I made up something on his age. If you add up all the ages I've been, including my age now, you get 1 year more than his age," he replied. "And the sum of the two digits of his age is my age." What were the two ages? So, we're going to be using some variables here. Let's say for David, let's say his age is X. And for the grandpa, his age is going to be a two-digit number. And because it says the sum of the two digits, so we're going to write it as a YZ. Okay? A two-digit number which you can decompose as 10y plus z. Okay, so we're gonna go ahead and use the requirements given in the problem. Let's go ahead and put that into an equation. So the first sentence says, if you add up all the ages I've been, including my age now. So this is David talking. So if you add up all the ages of David, meaning that you start with 1, okay, and then 2, and then 3, all the way up to X, because you're supposed to include the age now, okay? This sum is equal to 1 year more than the grandpa's age. And as we know, grandpa's age is 10y plus z, so this sum is going to be 1 more than 10y plus z, okay? All right. And then we have another equation that says the sum of the two digits of his age is my age. So if you add up the digits of grandpa's age, which is y plus z, right? That should give us x. So x is equal to y plus z. All right. So we basically get a system of two equations here, but the solutions need to be integers. Okay? So let's take a look at different cases. Well, first of all, we're going to be simplifying the first equation. The sum of the integers 1 through x is going to be x times x plus 1 divided by 2, right? And that should equal 10y plus z plus 1. If you go ahead and cross multiply here, you should be getting x times x plus 1 is equal to 20y plus 2z plus 2. Okay. Now, at this point, we do know that x is equal to y plus z. So if you go ahead and replace x with y plus z here, we're going to be getting an equation in y and z. But let's go ahead and try to simplify this by not getting rid of the x. So we're going to keep the x, but let's go ahead and replace, for example, z with something. Okay, so what I'm going to do here is I'm going to isolate z from this equation, and that's going to give me x minus y. Okay, I don't want to get rid of the x because it's going to give me a nice quadratic which I can use. So let's go ahead and do this replacement. Replace z with x minus y. That should give me x squared plus x is equal to 20y plus 2 times z, which is 2 times x minus y plus 2. And then if we go ahead and simplify this, we'll be getting x squared plus x is equal to 20y plus 2x minus 2y plus 2. Okay, so what we're going to do is we're going to put all the x's on the same side. So let's go ahead and do that and simplify here. So if you subtract 2x from here, you get x squared minus x. And then if you combine like terms, 20y minus 2y is equal to 18y plus 2. Okay, now we have a quadratic equation on the left-hand side. It's quadratic in x. But it's not helpful if it's not a perfect square. So let's go ahead and do the following. Let's multiply both sides by 4 so that we can get 4x squared minus 4x is equal to 72y plus 8. Okay, so I basically, what I did was multiply both sides of this equation by 4. Okay, and this one as well, so like this. Okay, let's continue. So what can I do from here? Basically, I can just add 1 to both sides, and that should give me a perfect square, right, on the left hand side. So I get 4x squared minus 4x plus 1 is equal to 72y plus 9. Okay, by adding 1 to both sides, now I'm going to be getting a perfect square, which I can write as 2x minus 1 squared. Okay, and then the right hand side is just going to stay as 72y plus 9. Now at this point we're going to be using modular arithmetic. Now if you take a look at this, the right hand side is a multiple of 9 because I can write it as 8 times the quantity 8y plus 1. Okay, x and y are integers, so this needs to be a multiple of 9, meaning that the 2x minus 1 quantity squared is a multiple of 9, meaning that 2x minus 1 is a multiple of 3, right? So I can write the 2x minus 1 as 3k, where k is an integer, right? Okay, so what I'm going to do here is, basically by doing that, we can replace 2x minus 1 with 3k here. That's going to give me 9k squared, 9k squared. And then I'm just going to go ahead and compare it to the equation in y so that I can get a nice expression for y here. I'm going to cancel out the 9's, and then I'll be getting k squared is equal to 8y plus 1. Let me go ahead and rewrite that. K squared is equal to 8y plus 1. Now this is an important result because, and we also know that y is a digit. If you remember, yz was grandpa's age, so y needs to be less than 10. So this gives us a restriction on the values of y. And I can actually solve this because there aren't that many perfect squares that are in the form of 8y plus 1 when y is less than 10, right? So let's go ahead and check some of the k squared values here. Which ones is going to work? For example, if y equals 1, then k squared can be, so for y equals 1, k squared is going to be 9, which means that k is going to be 3, right? When k is 3, if you can just go ahead and substitute here, x is going to be 5 from here, right? And how do you find the value of z? Well, if you go back here, you do have an equation in x, y, and z, or you can just use the fact that x equals y plus z. That would be helpful, right? So let's go ahead and copy that here. X equals y plus z. And what you can do is, since you know the y and x values, you can just go ahead and substitute and find the z value as 4 here. So that's actually going to be one of our order triples. And let's see what this is going to give us. Or maybe we can just go ahead and solve for all the cases. Okay, let's take a look. We can also, how can I make this a perfect square besides using y equals 1? Well, I can also use y equals 3. And that gives me k squared equals 25. Meaning that k equals 5. And if k is equal to 5, okay, then x is going to be, because 2x minus 1 is equal to 3k from here, when k is 5, x is going to be 8. And since x is y plus z, or I can basically say that z is equal to x minus y, then from here z is going to be 5. Okay, that's our second order triple. And then we can still get more values if y equals 6. Okay, Then 8 times 6 is 48, plus 1 is also a perfect square. And notice that y is still less than 10. So from here, k squared is going to be 49, meaning that k is 7. And since k is 7, x is going to be 11. Okay? X is going to be 11. And z is going to be x minus y, which is 5. Again. Okay? So let's go ahead and put all these values in perspective, writing the name, the ages of David and Grandpa, and then we'll see which ones make sense. Okay? All right, so if you remember back to the beginning, David is x years old and Grandpa is yz years old. So the x value gives us the age of David. Okay? So, but Grandpa is more important here. So we said that yz is going to be Grandpa's age, right? Okay, so are all the yz values acceptable? Let's go ahead and check that. From here we get Grandpa as 54. Okay. And x is going to be, I'm sorry, it should be not 54. I messed up, sorry about that. It's supposed to be yz, so that would be 14. So Grandpa, in the first case, let's number these cases, 1, 2, 3. In the first case scenario, yz is going to equal 14. Obviously, Grandpa cannot be 14 years old, right? Especially when David is 5 years old. Okay. Okay. So x equals 5. This is not a valid solution. Let's look at the second case scenario. In this case, yz is going to be 35. Where x equals 8. Okay. Again, that's not very reasonable. Grandpa is probably older. And then let's look at the third case scenario, meaning that yz is equal to 65, right? And x equals 11. So this means that Grandpa is 65 years old and David is 11 years old. Thank you for watching. This is puzzle number 3 in the puzzle series. Do not forget to like, comment, and subscribe. See you in the next video. Until then, take care. Bye-bye.